Welcome. Today we're addressing a critical challenge in the rapidly evolving landscape of artificial intelligence, ensuring robust platform security and compliance within GenAI ecosystems. As these powerful tools become integrated into enterprise workflows, protecting sensitive data is paramount. We must develop comprehensive strategies that account for the unique risks and complexities introduced by generative AI systems to build trust and maintain regulatory adherence. GenAI introduces unique security challenges that necessitate a heightened level of vigilance. Firstly, these models act as significant data magnets, processing vast amounts of information, much of which can be sensitive. This creates new attack surfaces that malicious actors can exploit. Furthermore, the novel ways GenAI interacts with data and generates outputs can lead to unforeseen regulatory risks, making traditional security paradigms insufficient. Building uncompromising data protection for enterprise GenAI requires focus across several key competency areas. We need to establish strong foundations in compliance and privacy by design, embedding legal and ethical considerations from the outset. Preventing unintended exposure through secure output and leakage prevention is vital. Protecting data during the AI's processing phase falls under secure processing and model interaction. Finally, safeguarding data as it enters the system is covered by secure data ingestion and anonymization. The first critical layer of defense is securing data ingestion and ensuring proper anonymization. This begins with data classification and tagging, automatically identifying and labeling sensitive information like PII and PHI. Robust encryption controls are essential, utilizing TLS or VPNs for data in transit and strong encryption at rest for all stored data. Finally, data masking and tokenization techniques must be applied to replace sensitive identifiers before data ever reaches the GenAI models for processing. AI-assisted techniques can significantly enhance data masking and anonymization efforts. These tools can automate PII redaction, intelligently identifying and replacing sensitive information within unstructured text like customer transcripts. They can also help define and apply sophisticated anonymization rules, generating techniques like hashing or generalization, suitable for complex datasets such as patient records. Furthermore, AI can aid in synthetic data creation, generating realistic yet privacy-preserving datasets for testing and development purposes. Moving to the next critical layer, secure processing and model interaction focuses on protecting data while the AI is actively using it. This involves utilizing isolated environments to prevent data leakage between different processing tasks or models. Rigorous input sanitization is necessary to mitigate prompt injection and other adversarial attacks. Crucially, ephemeral handling of sensitive data ensures that temporary data used during processing is not persistently stored, minimizing the window of exposure. The third layer, secure output and leakage prevention, addresses the risks associated with the AI's generated responses. Output validation mechanisms are needed to check for the unintentional inclusion of sensitive training data or internal information in the output. Content moderation systems can help filter harmful or inappropriate content, which might also inadvertently contain sensitive details. Comprehensive audit logging of all inputs, processes, and outputs is essential for monitoring, incident investigation, and demonstrating compliance. The final layer integrates compliance, auditing, and privacy by design throughout the entire system lifecycle. Privacy by design integration means embedding privacy considerations into every architectural decision and development stage. Compliance mapping involves clearly documenting how data flows align with regulations like GDPR, HIPAA, and CCPA. Proactive threat modeling is necessary to identify GenAI-specific attack vectors. Finally, having a defined incident response plan tailored for GenAI-related security and privacy events is crucial. Consider the use case of building a privacy-preserving AI for healthcare, where protecting protected health information, PHI, is paramount. This requires a layered approach. PHI tokenization replaces identifiers at ingestion. HIPAA-compliant processing ensures data is handled securely, often within a private cloud. Output validation rigorously checks AI responses for any accidental PHI leakage. Finally, human review by clinicians provides a critical failsafe before any AI-generated output is used. ensuring patient data remains protected at every step. To build enduring trust with GenAI, focus on these key takeaways. First, prioritize classification. Understand the sensitivity of your data before implementing GenAI solutions. Second, collaborate broadly. Security is a shared responsibility, requiring partnership with legal, compliance, and cybersecurity teams. Third, implement layers. Use multiple, overlapping defenses throughout the data lifecycle. Finally, monitor and adapt. The threat landscape evolves, so continuously update your security fortress as new risks emerge.